Good morning, everyone. My name is Sharanteya, and today I am going to present on the topic high tech, high security concerns in graphic databases. In today's digital world, data is everywhere from the social media to banking systems. But what makes modern data powerful is not just the data itself, but how it is connected. This is where database come in, and with the great power comes in serious security challenges. So today I will be explaining what is graph databases are, why they are important, and most importantly, what security risks they bring, how to handle them. Introduction to graph databases. So let us begin with understanding what a graph database is. Traditionally, databases store data in tables, rows, and columns. But real world data is not like a table. It's highly interconnected. For example, friend in a social network, transaction between banks and bank accounts, device connected in a network. Graph databases are designed specially to handle this type of connected data. They use nodes and edges, where nodes represent entities like people and accounts, etc., and edges represent relations like friends with a transfer to like that. And think of it like a network diagram where everything is connected. The biggest advantage is they can quickly analyze relations without complex joins. This makes them exactly efficient for real-time analysis. Why graph databases are important? Now the question is why graph databases are so popular. The answer is very simple. Relationship matters. Graph databases are faster for connected data, flexible when relationship changes, uh, efficient in inquiring relationships. Let us take some real world examples. Social media. Platform like Facebook need to know who is connected to whom, who like what, and second one is fraud detection. Bank detect fraud by tracking suspicious connection between accounts, repeated transaction in a network. And third one is recommendation system. Amazon or Netflix suggests products based on your behavior and similar user behavior. In all these cases, relationships are the key. Databases allow organizers to make smarter decisions faster. Basic structure of graph databases. Let us break down the structures in a simple way. First one is nodes. Nodes represent entities. Example, person, bank account, product, like that. And second one is edges. Edges represent relationship between like follows, transfer money to whom, like owns, like that. And third one is property. Property store details like name, age, transaction amount, and data. Example, banking system. A customer is question node, a bank is question node, and a transaction is an edge, and amount and data are properties. Together, this form a connected graph network. This structure allows a quick tracing of relationships, which both powerful and risky. Next one is need for security in graph databases. Now let us move the most crucial part, security. graph database store, financial data, personal information, social connection. The biggest issue is a small data leak can expose an entire network. The biggest, for example, if one account is compromised, an attacker can trace all related accounts. Security is required to ensure confidently, confidentially, data should be private, integrity, data should not be altered, availability, data should be accessible when needed. Without proper security, data can be stolen and relations can be manipulated and system can be crashed. So security is not an option, it's an essential. Next one is major security concerns. Let us look some major threats like unauthorized access and weak authentication and injection attacks, data leakage, insider threats, and poor authentication controls, and privacy risks, and monitor complexity, and privacy risks due to relationships, and difficulty in monitoring all this stuff, etc. So the key difference from the traditional basis is in the graph database, the data is connected. So if one part is attacked, the attacker can explore the entire network. This makes attacks were more dangerous and harder to detect. So unauthorized access and weak authentication. Unauthorized access means someone enters the system without our permission. So common reasons are like weak data passwords, um, default credentials, no multi-factor authentication. For example, if a hacker guesses a password, they can access the entire graph database. So they can view confidential relationships, modify connections, and delete the data. So solution is by keeping a strong password and keeping a multi-factor authentication and regular monitoring. Authentication is the first line of defense. Injection attacks. Injection attacks are very dangerous. They occur when attacker inserts miscellaneous inquiries, like graph database use inquiry language like cipher and Gemlin. If user input is not validated, attackers can manipulate inquiries. For example, instead of a normal inquiry, attacker injects command to like read hidden data, like delete nodes and change relationships. They can break the entire system. So the solution is input validation and parameter inquiries and secure coding data practices and never trust user input blindly. Data privacy and relation exposure. This is a unique challenge in databases. Even if the data is anonymized, relation can reveal identity. Example, if you know a person, friend, location, and behavior, you can identify them. Privacy risks include like social relationship exposure and financial connections and behavioral profiling. This is very critical in healthcare, banking, and social media. So, database reveal hidden patterns which can be misused. security measures, and best practices. Now, let us discuss solutions to secure data graph databases. First one is strong authentication (MFA), and second one is role-based access control, and next one is data encryption and input validation and active monitoring, regular audits and software updates, limited permissions, and employee training. Security is a continuous process, not a one-time setup. Organizers must always stay updated with new threats. At last, conclusion. To conclude, graph databases are powerful tools. They are essential for modern applications, but they introduce serious security risks. Main concerns are unauthorized access, injection attacks, privacy issues, and insider threats. With proper security measures, we can reduce these risks. The goal is to balance innovation and security. Thank you.